Hi guys, this is a Test Electronics video demonstration of accessories for the prober style test fixture that plug into the rear and front panels. Now what these are, starting from this side, is a power entry module. You just put your power in here, you got a switch and you've got voltage, amperage and frequency that's registered, and a fan. Same with this one. This is a power supply, a power entry module plus a power supply. This is a fan that runs off 12 volt and it has a temperature sensor. This is another type of fan that runs off 120 to 240, just like those, and these are data entry modules. I just wanted to go over these really briefly. You don't even have to understand it just yet. I'll go over these in more detail in a moment. What I want to do now is show you what these look like. I'll slide this back and show you what these look like installed in a fixture so you get a better idea of what's going on and what we're trying to build here. So here's a 10-inch prober style test fixture, and this is what a power supply module looks like from the back, and a data entry module, which is actually configured. This is a data I/O, I should say, not just data entry, because you can put USB in here, but that's plugged off because there's a Raspberry Pi in here. And so what this has is two USB out ports. This is blocked off, and then it has power out. And that's to power something like a hand scanner or a printer, stuff like that. And then you have Ethernet to go into your Raspberry Pi. Okay, so let me show you the inside. So basically, here's the power supply. The AC part isn't connected yet, but will be. This goes to, the 12 volts goes to basically a USB hub built in here, which is this thing, the data entry module. And the power goes out to that, powers the hub, and then also has a jack out here for it. USB from the Raspberry Pi. This is the Raspberry Pi. This is the Ethernet input. USB output goes to USB input here, and then that goes out to all the hubs. And all these hubs, all these USB cables then go out to all the different data acquisition boards. Like this one here is a switch. This here is analog. No, this is digital, this is analog, and this is an RF type switch, and this is a filter. So that basically shows how things are mounted in the fixture. That's what I want you to see. And same with the front. This is missing because what goes there is this. It just mounts. So they just mount up like this, right in here, and then you put your two screws in and it's mounted. And so might as well just start with this. It's got a start-stop button and a bunch of status indicator lights. These are all controlled and monitored by a USB cable. So all you have to do is run one USB cable to here and everything's done. You got power, you've got all your, almost everything's done. You got to also run, there's another terminal here for the other switch, and that other switch is, it's the lid switch, which is basically right here, if you can see that, the lid switch. So that goes into there. So, okay, that covers that one. Another one I wanted to show you is a filter. Not a filter, but a vent. So if you have a fan in the back, you can vent it out the front. You can also vent it out the bottom if you want to get a vented bottom panel instead of a plain bottom panel. But if you have the plain bottom panel and you want to vent, real quick way to do it is just to get a front panel vent and mount that in there. Okay, so that's that. Now, let's go over this stuff in more detail. I just wanted to briefly give you an overview of what's going on so it's easier to understand what we're trying to accomplish with all these. So, I'll just run you through how these things are installed. Basically, when you get a fixture kit, it comes usually with a panel. Now, some of you people overseas may have this rear panel. You will receive this fixture with the rear panel removed, because customs needs a way to inspect your fixture. Get a better screwdriver so I can undo this a little faster. So basically, you just take out the panel you have, and you can modify this panel if you want, cut it. You can even buy blank panels from us in whatever size you want. So you just count it by the pairs. Like this would be a 1 panel, this would be a 2 panel, a 3 panel, and a 4 panel is the maximum. This is a 10-inch fixture. The 12-inch fixture will have a 5 panel in it. And the 8-inch fixture, which is a little smaller, will only have a 3 panel in it instead of 4. Okay, I should have taken this one off last, but let me put my... Oh, okay, let's take off the bottom cover first. So a good lesson for you, don't take off the don't try to undo the back without first taking off the bottom cover. It makes it a lot easier to take the bottom cover off. And to take the bottom cover off, you remove those 2 screws and slide it back and forth, and it comes right off. Now, let's take the bottom panel off. I don't want to block what I'm doing here. Just unscrew that, and the bottom panel comes right out just like that. And I've demonstrated it before where you lift it out through this, but you don't need to do that when it's not wired up yet. Okay, now, so the way these work is, say this power supply, for example. Now the fixture's upside down, remember? So it would mount in just like this, and you put your screws in, and it uses three bays, and you would have another bay left for, say, a data entry module. Now, this is the USB hub board, and it's normally mounted there, but I don't have it mounted right now because we don't. Okay, so that would mount right here like that, and this would mount like this. And basically that would fill up this 10-inch fixture. So if you wanted to mount something else, you couldn't do it with this setup. What you would have to do, these go together and it looks nice. There's not a big hole in the middle like that. When the screws are all in, it looks like this. Okay, so what you would do if you wanted more room, you would use, say, the next size smaller, this. And then you would have an extra bay. And you can even go one size smaller, which is this one. Now, there are some disadvantages to these. I'll go over that. Well, I'll go over it now. The disadvantage to this is the airflow is about half of what this is. Well, no, actually it's about 75%, not quite, not that bad, not half, but it's not as high as this one. These two have the same airflow, even though one is smaller. It's the same exact fan. It's a 100 to 240 volt fan, 50 to 60 hertz. And the difference between these is the filter. Okay, nowadays, a lot of you are still used to the old-fashioned way of putting the filter on the outside. A lot of people now put the filter on the inside and then put a mesh on the outside because people would knock the filters off, take them, move them, whatever. This way they're protected and you can kind of control when the filters are changed if they're on the inside. But if you want to put it on the outside, you can't use this one because this one is designed, what you could say, out of the red lines. Basically, this has to overlap here in order to fit. So it's kind of extended to the max plus a little bit more, and everything works fine except if you try to take this filter and put it on the outside, it won't fit. So that's why we have these two. This one you can customize this in any way you want. That one you can only have the filter on the inside. Okay, more things to look at. Power supply. Okay. So say you want a power supply, and you're going to want a data entry module, and you need a fan. You have two choices with a power supply. You can get this 12-volt fan, which is a blower type fan. It has the blower blades in there, and it has a little grill here where it has somewhat of a filter. It's not as good as those filters, but it'll filter out big particles. And that mounts like this. And you still have a lot of room. Or you can have this fan. This one also runs off 12-volt DC instead of AC. This one runs off AC, so it doesn't load down your DC power supply, and it's a little bit bigger. So that's your choices there. Now, for the front panel, I'm going to go over these a little bit more too. Well, I should go over the power supply. So the idea of mounting a power supply here instead of on the rail is that if you don't want a fan, and a lot of people don't because of the hassle of the filters and everything, the power supply is the thing that dissipates the most heat. So this is a 12-volt 5-amp supply, 60 watts. So it would dissipate a lot of heat in there. In fact, a 60-watt power supply is what I had behind this other thing. This is a Meanwell power supply. It's 12-volt 5-amp. Same as this. Same kind of thing. But this mounts on the rail. It'll mount here like that. So, see if you can see that. So what you would need is a fan, of course. If you have something that's dissipating 60 watts inside this fixture, it's going to warm up. With this, the heatsink is on the outside. So, now remember, these are always upside down because the fixture is upside down. But it dissipates out here instead of getting inside and warming up your fixture, basically. Okay. So now, on the rail inside, you can mount, you saw how I mounted circuit boards on the other fixture. Basically, you just mount it to this rail, and this is an adapter that we sell for, these are mostly for Overton Instruments. It'll fit every one of their boards. It's drilled to fit in one way or another, and it's screwed down so it will lock in place really good when it's being shipped. Now that being said, other stuff doesn't, like the Meanwell power supply. It's good to lock it down for on the benchtop use, but if you go and ship it somewhere, this falls off the rail and then it'll go through and crush all your test pins. So that's really an important thing. You don't want to have this mounted on the rail like that and fall off during shipping vibration and knock a bunch of test pins. These aren't so bad though, but most disasters happen with the USB hubs. But anyway, there's a way to lock it down, and it's the same device. This device, only you use two of them, and what we do, I just think everybody should know this, is you lock this down with screws and then put some tie wraps around it before you ship it. And that'll lock this down so it won't fall out in shipping no matter how hard it vibrates. So, well, no matter how hard it vibrates, but it withstand pretty good vibration like that. Okay, so let's go over in more detail these accessories. All right. So we have the power supply. And I'll get this stuff out of the way. Let me fire one up for you so you can kind of see how they work. just go with this one for now. So basically it works like this. You plug your IEC connector in here, and you've got you put your cable here, and it's a screw terminal block, and you just plug it in like that. Now this is rated for 10 amps, this whole thing. You'll never need that much in there. So the way this works, and it's nice because it's safe. You got your power, plug in your power here, and let's see, let's plug in something. I pulled this out. We'll plug in a power outlet because I want to show you the functions working. So, okay, oh, it is on. Okay, I don't have power on the desk. Let me turn power on. Okay, now it's on, and that light will blind the camera, so take that off. Okay. See if you see that. Okay. And now let me turn this right side up. And you can handle this because it's pretty sealed. There's not much danger of any place where you can get shocked. So you can see here, maybe you can see, this says 122 volts, 0 amps, 59 hertz. I'm in the USA, 60 hertz is what it should be, but these aren't super accurate. And if you see a little bit of ripple here, that's not real. There's a little film that we don't remove until the customer receives it to keep it from getting scratched and marred in shipping. But okay, so what I'm going to do, I'm going to plug in this heat lamp, and 120 volts, 125 watts. That should be about 1 amp. We'll see how accurate the meter is. Let's plug it in. So, yeah, 0.9 amps. And basically, that just shows you. And you might wonder, well, why the heck do you care about the frequency? Because if you send this overseas and you have critical components in there, now these are rated, everything I have here is rated from 100 to 240 volts, 50 to 60 hertz. But stuff you put in the fixture may not work well at 50 hertz, and there's a lot of countries that use 50 hertz. Japan is one of them, and it's really complicated because it's not south, it's east. It seems like it's south. Western Japan seems like south, and eastern seems like north. But you divide it in half. One half uses the eastern half uses 50 hertz. The western half uses 60 hertz because western half uses our stuff that's from Hiroshima over, and the eastern half, like up in Hokkaido and stuff, uses 50 hertz. That's from Germany. So, and there are some 120, 50 hertz places. So you might have some problems where you move it from here to another country that has 50 hertz and you can't figure out why. Well, you'll see that they'll be able to tell you right away what the power is just by reading that off. So it's really handy for that. And also it's just handy to have the current because you know if something's not connected in the fixture, this should show some current. Okay, so that kind of shows this power supply. Concludes the demonstration of the power supply. These are, not power supply, power entry. This isn't a power supply, it's a power entry module. Oh no, let me show you one more thing about the power entry module. Okay, say you have a rail and you have, the neat thing about this is the way it's wired is line, neutral, ground. And the way this is wired, upside down here, is line, neutral, ground. So basically, you can take this wire, which is a 20 gauge wire, good for 4 or 5 amps, and plug it right into here and straight. It's like a flat cable, and you just plug it right in here, and it's all wired up. That's how easy it is to wire. Well, you'll get this part, and you'll have to put the 3 wires into these screw terminals here on your this is a Meanwell, but all other power supplies, it's kind of common to have ground neutral line all in line like this, and this just plugs directly into each other just like that. Really handy. So it makes it real super easy to wire up. I just kind of wanted to run that past you quickly to show you that. And same with the power supply. No, that's not the power supply. The power supply is here. This has line neutral ground and then minus plus for the 12 volts. Same kind of thing though. You put that three wire cable in and it just wires straight to the Meanwell. So you might want that, like say for example you need 5 volts in your system. Well, you could get that off the USB. But if you wanted some special regulated power supply, you could have one of these smaller Meanwells in here and then plug from power into this and power that up along with the 12 volts. You could also just power fans with it, or in all your circuit boards, your data acquisition boards and everything. And if you wanted something super clean, you could use a different power supply on the rail for less current. And this would be the one that supplies the big current for the hub and all the basic stuff. And then if you wanted something super critical, you could put that on the rail and then power it with the line neutral ground here. So that's what that's for. Okay, this is just a fan. And this is a blower with the temperature gauge. Let me fire that up real quick too so I can show you what that does. This needs 12 volts DC. I'll move this heat lamp out. We're done with that. 12 volts. We can get 12 volts on here. And okay, so this is a blower. It blows a lot of air out here, out the back, blows out the back, sucks in and blows into the fixture. And then right here is the temperature sensor along with a bunch of coiled wires, so you can put it anywhere in the fixture. And I just touched it with my finger. I'll put my warm finger on it and you'll see the temperature skyrocket up to 20. This is centigrade. And there. Now it'll go back down again. So yeah, that's kind of handy too if you just want to have a 1 block fan, or you need a power entry module with 1 block fan. We got that too. So, but this one at least has a little screen in front of it. This one doesn't. You got to use this in a clean room. Okay, so that's a demonstration of that. This is a touch screen. Mounts on the front panel, and it is 5-inch LCD display, 800 by 480 pixel capacitive touch. And so it's got basically HDMI here, USB for power, and your capacitive touch. And that's that. And actually, this is a 2 module. That's the smallest we have for touch screen. We have bigger touch screens though. This is a 4 module. And let's see if it says what it is here. Same kind of deal, HDMI. Doesn't really say the resolution, and I forgot what the resolution is, but it's a lot higher. HDMI, USB. I can tell you the resolution if you're interested in such a big one. It takes up 4 bays. Okay, now that pretty much covers all the basic things. If you wanted, say, just a power, all these power entry modules I'm showing you here have fans. except for the power supply one. And most people, they always want a 12-volt power supply. But if you just wanted a power entry module, I don't have it shown here. It's a 1-unit device. It's basically just, think of this, like you get that. And it's got this and the frequency current thing. So that demonstrates that. Now, a few other things I wanted to demonstrate. We'll put the fixture back up here. So the way the fixture is stock, it's just like this. You got your press down rods that you can adjust for the adjustable type anyway. This is the type most commonly used. This is not really how it's mostly used, okay? So basically, this is your Raspberry Pi board. And if you wanted to say, let's see if I can get a press down rod and show you. It's kind of big. Yeah. I'll go grab a press down rod really quick. Oh, I had one handy there. Another one. Here's one. Okay, so these press down rods, they're kind of big. I mean, you can press down here, here. There's a bunch of places you can press down. But what's better to do for small boards is, yes, you use press down rods in places like that, but you can't put a whole bunch of them in. I like to design it where we press down by the edge. So press down along the edge that sticks out. And then you put little press down fingers in here and here. Now, I shouldn't use that. That's going to confuse you. So what we do is, this is customized already. This is for some board that was this shape and had a flex cable that came out here, and it would press down, and there was some connector here, so these two prongs would stick in. But I can kind of show you on this what it's about. So these prongs would kind of stick in here, and you'd have two right next to each other, and they would stick in and press this down while the sides were hitting the edge and pressing it down. Like that would fit right there. But that's, I mean, it would be cut to fit this. You got to actually cut this material to fit this. Now this is FR4 material, and it's difficult to cut because you got to have a good vacuum system and stuff, or you'll ruin your machine. You can also get this bake light, or also called fake light, and we can cut this stuff. It's almost as strong as the FR4, but not quite as rigid. And so what you do with this is you mount it. See, these 4 holes will mount on these slides right here. So you just mount this with this side up, this side down. The chamfered side is up, so it would be mounted like this, and these would be moved out of the way. So you'd mount it here, and then you'd be pressing down by the edge. And then you could also have some press downs in the middle. So this would be perfect for the Raspberry Pi, to have one of these plates. And this is, when you get this, this is a blank plate with just these 4 holes. And you got to cut out this middle section here. So remember that. And then another thing there we have is, say you didn't want adjustable here, you just wanted a set area. So you'd get something like this. This is anti-static Lexan, has the same 4 holes, and you mount it on top instead of on the bottom, and then you just drill the holes where you need press down rods, thread them, and put this through. Or you could just drill holes and put 2 nuts, but I like to drill the holes and thread them. It's a little bit more accurate, especially if you're going to have fixed positions. Now, another thing, if you don't want to, if you don't want to make something fixed position, but you don't want people messing with your settings, we just have these basic simple covers, which basically you just press it on like that, and it's locked in place hard because there's metal in here. And you can get these from McMaster Car. It just comes in a big roll, but you got to cut it. And we water jet cut these because there's metal in the middle here. And metal something like this. This was water jet cut by mistake right in the middle of this metal. But there's a whole bunch of these. I don't know if you can see the ridges, but there's a whole bunch of these metal things, and that's why it grips so solid to this. So you just put these over, you adjust everything, get 3 of these, put them over it, and then you're pretty well sealed, because this keeps things from getting bumped and messed around and from people messing with these adjustments. Just something simple like that. Okay, other things, I think I've showed you, I showed you this for mounting boards. We have blanks too, so you can get this with just a blank piece of square sheet metal mounted to it, and mount your board, and drill the holes to mount your board to that sheet metal. Another thing we've got is perf boards, where you just do something like this. Basically, there's just a hole in the perf board, and you mount these two together like this, and then you can do that. That's a small one, and then we have the bigger ones like this. And yeah, there's just one hole. And you might think, well, this is going to wobble all around. No, it doesn't, because this fits tightly against the rail here, and that keeps it from wobbling. That's what this is. See, one hole, there's 2. That's just so you can reverse it, but only one hole is used. And this is just a hair below that, so it sits on the rail and doesn't wobble. Okay, I think that covers about everything. So, recommendations for beginners: 12-volt 5-amp power supply. I don't know, if you don't have a lot of current, a lot of stuff dissipating heat inside, you don't need a fan. Maybe this, but these are kind of expensive. They come from Overton Instruments, this board, and I can give you a price though if you're interested. And same with this, the data entry module in this form or this form with or without Ethernet. And basically it's a USB port with input and output capability. See, these two USB jacks are just tied in parallel, so you can use one or the other. You can put your USB in from this side, or you can put your USB in from the outside. Same with these 2 power jacks, they're just in parallel. So you can put power in this way, or put power in this way. So if you have a computer inside your fixture, like a Raspberry Pi or something, you just put your USB here and your power here, and then you can power the outside world with it. Okay. Yeah, that should describe everything. Okay, well, so yeah, for getting started, probably this for sure. If you don't want DC, maybe this screen. If you don't want DC, you can get one of these. It's up to you. Just a lot of accessories to think about. Write me and let me know your application. I might be able to help you more, because we have more than just this stuff here. This is just the majority of what we have, and I might be able to clue you in on more stuff we have. Okay, well, thanks for watching, and yeah, call me if you have any questions. Thanks for watching.